If you are someone who wants to learn sliding window technique, or if you are someone who wants to learn how to significantly reduce time complexity of an algorithm, or if you are someone who wants to learn fixed size sliding window technique and dynamic size sliding window technique, then this video is for you. So in this video, I am going to explain sliding window technique in detail. So please watch this video till the end. So let's get started. Alright, let's begin this video with this problem. The problem is given as find maximum sum of k consecutive elements, wherein array is given as 1, 4, 2, 10, 23, 3, 1, 0, 20 and the value of k is 4. Well, the question over here is, why am I talking about this problem? I was supposed to explain sliding window technique, right? So for your information, we are going to use this problem throughout the video to understand the sliding window technique. Okay, great. So before we directly jump to the sliding window technique, let's first understand this problem really well. So if you look at this problem, you will see three things. First is maximum, second one is sum, and third one is k consecutive elements. So long story short, basically we need to consider all the possible k consecutive elements, then compute the sum of it and eventually return the maximum of all the sum. This is the actual meaning of this problem. But you know guys, there is another way to understand this problem. Well, it turns out to be find maximum sum of subarray of size k, where value of k is 4. So long story short, we have to find all the subarrays, then compute the sum of all the subarrays and eventually return the maximum of all the sum. So this means maximum sum of subarray is exactly same as maximum sum of k consecutive elements. So let's see how it works. This is the given array and size of k is 4. So what do we do here? We find all the possible subarrays and sum of it. So we consider the first element first, and the subarray beginning with this first element is 1, 4, 2, 10 and the sum of these four elements is equal to 17. The next subarray beginning with second element is 4, 2, 10, 23 and the sum of this subarray is 39. Similarly, the subarray beginning from the next element, that is 2, is 2, 10, 23 and 3 and the sum of its elements is equal to 38. So we have to do this for all the elements till 3. Okay, why till 3? Because if we go beyond this 3, we end up with only 3 elements. Okay, but the constraint given in problem is k equal to 4. This means we have to compute the sum of minimum 4 elements. Okay, so after computing sum of all the subarrays, we end up getting 17, 39, 38, 37, 27 and 24. And you can see out of all the sum, the maximum sum we got is 39. So this is the maximum sum out of all the sum. So what we do? We simply return this value. So this is the basic approach to solve this problem. I hope everything is clear to you so far. So this brings us to next question, that how do we implement this approach in code? So well, let me show you the pseudocode of this basic approach to solve this problem. Here we are given an array and the value of k is 4. So what do we do here? We simply run a loop from 0 to n minus k, where n is equal to size of array and value of k is 4. And why only till n minus k? Because if we go beyond n minus k, we end up getting only 3 elements. And we have discussed just before. Okay, so we run a loop to select one element at a time, like 1, then 4, then 2 and 3, to find subarray beginning with this element. Then inside this outer loop, we are again going to run a for loop from 0 to 3. Because the value of k is 4, so we have to run a loop 4 times, 0 to 3, to compute sum of 4 elements. Okay, so in first iteration, the element is 1, so we compute the sum of 4 elements beginning with 1, because this is our first subarray. Okay, so the sum comes out to be 1 plus 4 plus 2 plus 1, that is equal to 17. Okay, in next iteration of outer loop, we consider 4 as next element. and this sub-array beginning with 4 has elements 4, 2, 10 and 23, and the sum of all the elements comes out to be 39, and we follow this same process for all the elements. Okay, and at the same time we keep track of maximum sum we have found so far. So this is the simple and basic approach to solve this problem. Okay, great. Now what will be the time complexity and space complexity of this basic approach? So if you look at this pseudocode, you can see that we are running a loop from 0 to n minus k, and then again inside of this loop we are running a loop from 0 to 3. Okay, so in worst case, if the value of n is very large, then we can assume that this outer loop runs n times and the inner loop is always going to run k times. Okay, so the overall time complexity of this approach comes out to be big of n into k, right? So what about space complexity? As you can see here, we are not using any extra space instead of just few variables. So we can say that the space complexity of this approach is going to be big of 1 or constant space. So if we use this simple approach to solve this problem, we end up getting big of n into k time complexity and big of 1 space complexity, which is very obvious, right? So this is all about the basic approach. Alright, so now comes the interesting part of this video, because finally we are going to learn sliding window technique. Okay, so let's begin. So if we split this phrase sliding window technique, we get 3 terms. First is sliding, second one is window, and third one is technique. Okay, so let's understand all of these terms one by one. Let's first understand the meaning of window. So here window refers to the number of elements, and that is equal to k. In case of this problem, value of k is 4. So this means k is the size of window, and in this window we have to consider 4 elements. Okay, as you can see here, this is a window, and in this window we are considering 4 elements, 1, 4, 2 and 3. So this is the real meaning of window. I hope this is clear to you. Now next term is sliding. Now this is the cool part of this technique, that if you consider this window, we can easily slide this window forward, forward, forward and then backward. So this is the ability of window to move forward and backward. This is why we call it sliding window. Okay, now what about technique? So technique basically means an efficient way of doing something. This is the simple meaning of technique. Okay, so I have explained the meaning of sliding, window and technique. So I hope now you understand what is the actual meaning of sliding window technique. So in this technique, we are going to consider a window. So we are going to slide this window towards the left or towards the right based on the problem statement. Okay, now this begs the question that how to use this technique to solve this problem. Now comes the really interesting part of this technique. So basically we are going to use this efficient sliding window technique to solve this problem. So let's begin. So here is the array and the size of k is 4. This means the window size is 4. So we have to consider 4 elements at a time. Okay, so what do we do in this approach? In the first step, we are going to run a loop from 0 to k to find the sum of first k elements. And the first k elements you can see over here is 1, 4, 2, 10. And the sum of these 4 elements is 17. So this is the first step and we are done with first step. Now moving on to second step. The second step is we are going to slide this window by one step towards the right. Okay, so after sliding this window, the new 4 elements fall under this window are 4, 2, 10 and 3. So as per the previous approach, we should be doing 4 plus 2 plus 10 plus 23 equal to 39, right? Well, this is not the same case here. And this is where the magic of sliding window comes into picture. If you look at these 2 windows carefully, in first window we have already computed sum of 1, 4, 2 and 10. And in the next window we are again going to calculate sum of 4, 2, 10, 23. Why is it so? Can't we reuse the previous computation? The answer is absolutely yes. We can use the previous computation to compute the sum of next window. But the question over here is, how do we do it? It's pretty simple. Let me show you. So if you look at these 2 windows, it only differs by one element. In second window, we are adding one number and we are simply without the first number. This means we are removing this number and we are adding this number. Okay, so this is the magic of sliding window, that we no more have to run a loop to compute the sum of k elements. We simply have to do is get the sum of previous window, add new element to it and subtract the first element of the previous window, and this is how we get the sum of next window. And the best part of this technique is we can compute the sum of next window in big of one time. Yes, you heard that right. In previous approach, we were running a loop k times to compute the sum of k elements, right? But here we do not need to run a loop. We can simply compute the sum of next window in big of one time complexity. This means the constant time complexity. Okay? I hope you like it. So the idea is pretty simple. First compute the sum of first k element and then slide the window towards right by one step and then compute the sum of next window using the computation of previous window. This is it. And then we are going to repeat the same step for all the elements till n minus k. And while doing this, we keep track of maximum sum we have found so far. So this is the entire approach to solve this problem using sliding window technique. So now it's time to see the implementation of this efficient approach. So here on the left side of the screen, you can see we have a function maximum subarray sum, and this function is taking array as input and k as input, where k is the size of window. Okay, inside of this function in step 1 we are getting length of the array. In next statement we are initializing a variable maximum sum to 0, and this is the variable which keep track of maximum sum we have found so far. Okay, after this statement we are running a loop from 0 to k to find the sum of first k elements and store that value in the current sum variable, and then we are storing the current sum value to maximum sum. This means we are storing the sum we have found so far in maximum sum variable. Okay, after first loop we are again running a loop from k till less than n. So if you look at this loop carefully, we are running this loop from k. Why? Let me show you the reason. In first for loop we have already computed the sum of first k elements, true? Okay, then in next for loop we are starting the loop from k. It means the value 23. So this means the value 23 is the last element of the next window. And what do we do in this window? We add 23 to the previous window sum and subtract the value of first element of the previous window. This is what we are doing here, and we are running this loop till less than n. N is what? N is 9 and less than n is equal to 8. This means we are considering all the elements from index 4 till 8, right? And how we are computing the index of first element of the previous window? Using this expression, ARR of j minus k. If j is equal to 4, then 4 minus 4 is equal to 0, and element at index 0 is 1. So in first iteration we are subtracting 1. In next iteration we subtract 4, and so on and so forth. And then we are storing the sum of current window in current sum variable. And after this statement we are finding maximum of maximum sum and current sum. If in case we found current sum is maximum than maximum sum, then we simply update the maximum sum to current sum, and eventually we return the value of maximum sum. So basically what we are doing here, we are storing the sum of each window in current sum, and then we are comparing this current sum with maximum sum, and if we found that the current sum is maximum, then we simply update the maximum sum with current sum. And you can see here, now we do not have to run a loop for k times. Instead we can compute the sum of next window in the blink of an eye. So cool, isn't it? Okay, so let's move on and quickly dry run this code and see how it works. So here is the given array and size of k is 4. The value of n is 9 because there are n elements in this array. We initialize maximum sum to 0 and then our first for loop begins. Before first for loop we are initializing current sum to 0 and then we are computing sum of first k elements, that is 1, 4, 2 and 0. The sum of these elements comes out to be 17. So we update the current sum to 17 and maximum sum to 17 as well. Now moving on, after this for loop the next for loop begins, and this for loop begins with j equal to 4, right? Because the value of k is 4. This means we are targeting this element. So how we are computing? We are just taking the sum of previous window, that is 17, plus new element, that is 23, minus the first element of the previous window, that is 1. It comes out to be 39. Then we compare 39 with the current sum and 39 is greater. So we update the maximum sum with 39. So far so clear. In next iteration the value of j becomes 5 and the value of k remains 4. In this iteration we are targeting this element 3. Okay, so 39 is the sum of previous window plus new element, that is 3, minus first element of the previous window, that is 4, is equal to 38. And we again compare this with the maximum sum, and this is not the maximum, so we keep maximum sum as 39. Clear. Moving to next iteration. In next iteration the value of j becomes 6 and the value of k remains 4. In this iteration we compute as 38 plus 1 minus 2, that is 37. Again this is not the maximum so far. Moving to next iteration. In this iteration value of j becomes 7. Value of k remains same as 4. In this iteration we compute 37 plus 0 minus 10, that is equal to 27. This is also not the maximum. Okay. In next iteration, and this is the last iteration, where j is equal to 8, k is equal to 4, current sum is equal to 27 plus 20 minus 23, that is equal to 24. This is also not the maximum. So out of all the sum, the maximum sum we have found so far is 39. So the output of this input comes out to be 39. So this is how this function is going to run. As you can see that this approach has done pretty much good job. But what about the time and space complexity? So let's find it. So the first loop we are running k times, and then second loop we are running n minus k times. So the overall time complexity of this function comes out to be big of n. This means we are only running loops n times, including first loop and second loop. And similarly, we are not using any extra space, so the space complexity comes out to be big of 1. This means constant space. So overall this approach took big of n time and big of 1 constant space to solve this problem. Now if you consider this approach with the previous approach, the time complexity of previous approach is big of n into k, and this time complexity is considerably larger than big of n, isn't it? If we get n is equal to 100, then this time complexity comes out to be big of 100. But in case of previous approach, this time complexity turns out to be 100 into k, that is 4, and that is equal to 400. And you can see that this is a considerably larger value than 100. So this is how sliding window technique help us to reduce time complexity significantly. So I hope this is clear to you. So this is all about the fixed sliding window technique. And in upcoming video we will learn how dynamic sliding window technique works and how we can use it to solve coding problems. So I hope guys you learned something valuable out of this video. If you did, then please hit the like button and subscribe to this channel. And do not forget to hit the bell icon so that you do not miss any upcoming videos. So this is it from my side. Thanks for watching and see you in the next one.